all the network traffic, I mean the internal network traffic, so this diagram should be read as a corporate infrastructure. So all the traffic is mirrored to network probes for an usage-based analysis. All the events, logs, and network traffic is also forwarded to the CM to be able to provide alerts, events, and providing also dashboards to the SOC analysts to detect both IT and OT attacks going on. Next slide. And this is the actual addition to our prototype, to our cyber platform. So we have the SCADA, which is modeled as a SCADA network where the workstations, SCADA applications and services are deployed and used by operators to monitor the status of the plants, but also to control them. And the service pulls and interact with virtualized PLCs, which acts as a middleware between the SCADA network and the simulated model. The simulated model is a Java application running on dedicated virtual hosts. And so what we achieved was to define a model of the physical interaction, physical measures, and what would happen in the real world when controlled by PLCs and controlled also by SCADA application, and potentially be also invoked and called by attackers. Next slide. So this is the general architecture of our platform. As you can see here, we separated the control plane from the execution plane, and we have here a trainer, user, and user. The general user is represents both the attacker, the defender, or the SCADA operators. Our system has the ability to deploy multiple instances of the same scenario, the same virtual infrastructure, which can include virtual machines and containers, and can also be interconnected with external hardware. And all the infrastructure, all the environments, there are sandboxes. So there is no way to communicate each other. All the traffic is also mirrored externally to provide a trainer additional information and network flows and statistics to monitor the execution, the status of the playground. And the last thing that I wanted to say before passing the presentation to Shahaya is that all the access to the platform is via a web application. So there is no need for VPN, special equipments, clients, and so on. Everything can be used by via web application. And the reason we decided to use this strategy is to be able to provide to be more user-friendly, but also to keep everything that happens inside, in the playground in a controlled environment without the risk of exposing users to potential threats or even to create additional, to extend the attack surface. And Shahaya will explain you the physical system and how it modeled the real world.
Perfect. Thank you. Thank you, Alberto. Well, one of the key aspects of the cyber range, as Alberto mentioned, is the addition of a dynamic, interactive simulation model of a physical system and its integration with the cyber range. Then the key idea over here is that once the attacker navigates through the network and gains access to the to a PLC or controller and changes certain parameters or set points, it has physical impacts on the system. And what we want to do was to understand and predict the physical system's response to such actions, keeping in mind the dynamics and time delays of the physical system. So for the purpose of this for the purpose of modeling this physical system, we resorted to using the program AnyLogic. And there's two reasons for that. Number one, AnyLogic is actually very good at doing system level modeling. And number two, it allows us to combine agent-based models, system dynamics, as well as discrete event simulations, all in the same model. And this allows our scenarios to be fairly complex. And we can model like complex system properties and stuff. Now, the other thing I want to note is that the way we actually implemented the connection between the cyber range and the physical model allows us to have multiple people connect into the cyber range, into the physical model. And what that means is that both the attacker and the defender can access the physical model and change parameters in real time. What you see on the right is a very simple example of a water tank simulation that we implemented in AnyLogic. Two valves and two limit switches, and it's a fairly simple system. And the simulation is rather trivial, but you can imagine that we just provided a proof of concept, and the same approach can be used to actually model more complex systems. And at the moment, the team is actually looking at modeling a water treatment facility using the same approach and combining other water water tanks with some other equipment. We also wanted to see what would, if we could apply the same approach to other systems, so energy system, for instance. And for that purpose, we decided to model a gas turbine, an industrial gas turbine. Now, for those of you who are not familiar, a gas turbine is basically, it's sometimes facetiously described as a rotating blowtorch designed to run at the ragged edge of self-destruction. What it really is that gas is burned to actually turn a turbine, which then generates electricity. Now, what I want to do is to demonstrate our gas turbine simulation model by walking you through a typical attack scenario. What you see in the middle of the screen is the HMI for a gas turbine. Now, the HMI is the human machine interface. This is the part of the system that the operator in a plant uses to interact with the device or the equipment. Now, this screen looks almost exactly what a real operator would see in a real plant. If I click on plots, I basically see a number of parameters and their time histories that may be of interest to the operator. Now, the first scenario that I want to demonstrate is where the attacker has gained access to the plant's HMI, the gas turbine's HMI. And the first thing you will notice is that the attacker can actually change the power output set point for the gas turbine. But as soon as he makes that change, a number of parameters change in addition to the power output from the gas turbine. For instance, you can see the angular speed is changing. You can see the fuel signal is changing. The exhaust temperature is changing. So there's a number of things that change. Now, most of the time, a gas turbine operates at what we call base load or 100% power. But for short periods of time, you have the ability to increase the exhaust temperature set point in order to operate the gas turbine at a higher temperature and just to pump out more power in times of need. Now, the key here is that it can be done for short periods of time. Well, an attacker who's not very well-intentioned could actually run the gas turbine at an extended temperature at a higher temperature for an extended period of time, thereby reducing its service life. So this is exactly what we see in this scenario where the attacker is changing the peak load set point and then changing the power output. And what you would notice is that as soon as that change is made, again, all the different interconnected parameters of the gas turbine change with respect to time. And in this particular case, the attacker is going back and forth and changing the power set point too high to too low and basically causing thermal fatigue and that kind of damage. The point is that for the purpose of this presentation, we targeted the HMI, but the same scenario could be done just as easily by using Modbus commands or other industrial protocols, where the attacker could change the set points while spoofing the HMI screen, so that the operator thinks everything is normal, but in reality, it's operating at a higher temperature. The point is that a trained operator who has been exposed to this type of training would be able to recognize that it's not just the temperature, exhaust temperature that that is being changed, but all the other parameters are also changing. He could use that information to understand that something is not right and report to the IT security to look at that specific time frame where he first noticed this anomaly. So that's the first.
Sorry for interrupting you. You have 1 minute left.
Sure, thank you. All right, and likewise, at the same time, the IT security analyst can also develop an intuition about the criticality of certain controllers and what it means when certain commands are issued by these controllers. So in conclusion, that's ultimately the main goal for our cyber range, which is to train an army of people who can defend our cyber infrastructure, industrial control systems against cyber attacks, increase ICS awareness for IT operators, enhance cyber awareness for OT operators to have them act as our eyes and ears in the field, and ultimately bring IT and OT together to improve our cyber resilience. As far as next steps are concerned, we're exploring several ways to improve our cyber range, looking at moving part of the logic outside of any logic to improve detection rules, generate feasible attack scenarios, etc. And there's a bunch of other projects as well, but together, we believe that these projects would advance the cyber training field, close the gap between IT and OT, and ultimately lead to more resilient energy delivery or industrial control systems. With that, I'm actually at the end of my slide. Just want to acknowledge all the people over here who've contributed tremendously to this project. Thank you.
Thank you very much, Sarjar. So first of all, I have to apologize because I didn't introduce Alberto, actually. So I only introduced you at the very beginning of the talk. Thank you very much for the talk. It was really, really interesting for me, and I think for most of our audience. So as usual, are there any questions from the audience? Okay. Which is much better for me because I have one question and I'm very interested in what you showed us. So since we don't have much time, only just one question. In terms of scalability, because I think what you showed is very interesting and very useful for the current scenario of this kind of system, this kind of training context. But I would expect that in general you need to develop something which is much more complex to, let's say, allow people to train in an environment that they recognize as realistic. Okay, so I think that a very interesting point is scalability. Do you have something to say about this?
Yes. So the one thing is that for the first part is that we're using the 80-20 rule. So basically, with 20% of effort, if we can capture 80% of the market, capture 80% of the training exercise, that would be great. That's our initial answer. But at the same time, one of the projects that that we're working on is looking at some pre-made simulation models in programs such as Modelica and other simulation languages, and see if we can integrate that with any logic and then with the cyber range, so that the complexity is taken care of by somebody else, but then the higher level interaction between the different pieces, that's something that's handled by any logic, and then we can interact with the cyber range using that. That's an idea that we're working on in the future.
Very, very interesting indeed. Okay, thank you very much. So I would move to the last speaker. So Marina, can you hear me?
Yes, I can.
Yes, I can.
Yeah, perfectly. So let me share your slides. So just so all the audience is aware of, Marina cannot share her slide and cannot switch on camera due to WebEx, which allows me to say a couple of things. The first one is that WebEx is not friendly, is a bit discriminating toward the people using Linux like me and Marina. So Marina, you are a sort of Rosa Parks for me now. You are our Linux Rosa Parks, let's say. and thank you for that very much. And also this allows me to present your slide. Let me share my screen. Okay, you should see. Okay, you should see your slide, right?
Not yet.
Okay, why? Well, I see you are sharing Microsoft Edge, which should be this screen. Can you see something?
No, not. Maybe the others.
I need help by Alberto. Alberto, can you see my screen?
No, I cannot. So if you give me a minute, I can try to solve this.
So if I do share, I see Microsoft Edge. It is my browser that I want to share, right? So I do share, and I get the focus there.
Okay, now it's it.
Okay, that's fine. So the first time didn't work actually. So let's go to presentation mode. So Marina just asked me to move to the next slide when you want. So we cannot enjoy the view of Marina. That is bad news for us. But on the other end, Marina, you can wear your pajama if you like during the presentation. Okay?
Yes. Thank you.
Thank you very much. I will inform you when you have 1 minute left.
Okay. Thank you. You should switch off. I apologize for this inconvenience. I spent all the morning trying to install VirtualBox and the Windows machine, and in the end it didn't work. So I moved back to my Linux machine, and so I cannot share the screen with you, but Gabriele will do that for me. So let me introduce me. I am Marina Ribaudo, and I will present a joint work done together with the colleagues Giovanni Lagorio and Alessandro Armando. And the title of the presentation is Capture the Flag Competition for Higher Education. It is a work on education, different from the presentation I've seen so far. So I'll ask Gabriele to go to the next slide. Next, so that let me introduce my agenda. So I have one slide of introduction of the project. Then I will tell you what we did with our student in a project called Ethical Hacking Boeing Unige project. Some results withdrawn after our experience, and then the lesson learned and some conclusion. Next, please. Okay, so this is really an experience we had as educators at the University of Genova. And because thanks to the support of a big company, the Boeing company, we had the chance, the opportunity to create a training program on ethical hacking for our university students. So the program was for computer science and computer engineering students in my department. Our main goal was to attract more students to approach cyber subjects. And we think it was also a good opportunity for them because, I mean, because there is a skill shortage in this marketplace. And so we want to attract more students because we are sure that they can have a very good career in this field. Next, Gabriele, please. So therefore, we started in 2007 with a project on ethical hacking, and in 2017, we had a pilot experience, and we invited students to attend our meetings on ethical hacking, which were very informal and on a voluntary base. We call these meetings Friday hacking events because they were on Friday afternoon. We didn't want to have any conflict with official classes. And the focus there was on hands-on experience. So we did not have any cyber range. We did different type of exercises, but it was really focused on hands-on activity. The success was quite good, and therefore, in the next two editions, in 2018 and 2019, Professor Armando, who is teaching computer security, decided to make this kind of training mandatory for the students, the master students in computer engineering attending his course. And on average, we counted at the end of the training, on average, 75 students in the last 2 editions. So the training lasted for 3 months, and we had 1 meeting each Friday afternoon. Next, please. Okay, so here it is a picture of a class during one of our meetings. As you can see, it was quite crowded at the time, and we were presenting some theory and then asked students to do some exercises, and we were with them. As you can see, students were asked to bring their laptops with them, because these meetings were really practical, hands-on activities. Next, please. The topics covered during the meetings are mainstream in ethical hacking. So we did some Linux basic for the students that were used to use Windows, something on programming, mostly Python scripting, because Python is a language we do not teach in our bachelor degree, and then something about network protocols, web security, binary analysis, and cryptography. And of course, if the teachers do not have their own set of exercises, it can be a nightmare, but we could use the very many platforms which are available and offer specific exercises for this type of education. Next, please. Hopefully, in the second edition, we were able to build our own platform with exercises, which are still used. We are still using it for training, and the name of the platform is the Zen Academy. And this is because we have a CTF team of players. The name of the team is Zenac. Zena is Genova in the dialect, and so it's hacking in Genova. And so we thought that the Zen Academy was a good name for this type of activities, also because members of the teams were indeed trainers and instructors in our project. Next. And each year, at the end of the training, we have organized an on-site Jeopardy CTF competition of 4 hours with prizes for the best performing students. And here, in the last edition, we needed to tackle a kind of problem, because to meet the dual role of this competition, which is a competition among students for a grant, but also the hands-on part for the computer security class, we needed to think of 2 different types of challenges. And so we decided there were some challenges labeled with a star, which were specific for the exam. And these challenges could be easily solved by studying the course material without any need for lateral thinking, which is so important when you have to solve a real CTF challenge, because you need to understand, to think like an attacker, and to understand where is the vulnerability to find the exploit. Next, please, because I think now I have pictures of our on-site CTF. So this is the 2017 edition. And each year we have a different t-shirt. That's the yellow edition. And you can see Gabriele. Yes, Gabriele was with us at that time. And so in the middle, you can see the trainers and then the students, and they were all happy to be there. In the next slide, you will see the 2018 competition. We decided to change t-shirts and to have a different t-shirt for the staff. So the red t-shirt are for the staff, and the blue t-shirt were for the students. And I think that these students also, even those who didn't got the best position in the ranking, were at the end of the event, which is quite funny, we're also happy for our t-shirt. And so in the last year, in 2019, it was the last, it's in the next line, and so we moved to the green and pale blue teams, and we were lucky. This CTS was on site, and after that, we went into pandemic COVID. So it was one of the last events we could do on site in December 2019. If you go to the next slide, I will show you now some results we gained by analyzing the data, some different types of data we collected, because we, at the end of the training, we did some questionnaires what are our students, and then we collect also the results of the CTF and the markings of the computer security written exam. So probably I'm a little bit too slow. Gabriele, go to the next slide. I will try to be faster. So the research question, the first research question was, we wanted to understand how much that did this hands-on training improve students' cybersecurity skills. Next one, and to understand that, we asked students to self-evaluate their competencies before and after starting the training, the competencies on different topics, and we use a 5-point Likert scale ranging from very poor equal to 1 to very good equal to 5. And in the next slide, you will find the results. So, okay, go ahead, go to the next slide because I'm running out of time. Here you can see that in both editions, students felt they improved their knowledge, of course, after the training, but for all topics except for programming. So there is a tiny difference between evaluation of programming before and after the training. And if you go into the next slide, Gabriele, we can see also the distribution of the answers for programming, where you can see, in fact, that they improved because the number goes to the right-hand side of the picture, but not so much. And we explain this fact by the fact that they already knew how to program before starting the training. So it wasn't a new topic for them. If you go to the next slide, Gabriele, we can see how much was the improvement for one of the most difficult topics, which is binary analysis. Binary analysis was only for the competition, not for the exam. And as you can see, in both editions, students evaluate themselves with a very poor knowledge before starting the training. And then after the training, so they were much more self-confident on themselves on this topic as well. And so these numbers allows us in the next slide to conclude, to summarize that yes, the respondents declared their competence improved after the training, but this is less obvious for programming, which is a subject they already knew. I have other numbers to show you if there is time, and so we have research question 2, which is not in the slide because I knew in advance I wouldn't have time, but another question was about the appropriateness and the effectiveness of CTF-like activities for official evaluation. So these are the numbers of the students attending the CTF in the 2 editions, 71 in 2018 and 73 in 2019. And as you can see, a small group of them was there for the exam, 20 students in the 2018 and 34 in 2019. And so we analyzed their results in the next slide. And so the results of the CTF were normalized in between 0 and 4. And 0 means fail, and 4 is the maximum markings they can get. And as you can see, in the first edition, some of the students failed. So they didn't pass this part of the exam. Of course, there are other possibilities, there are other cyber exercises organized, but they failed during this more formal competition. This did not happen in the second edition, we think, because students were alerted by their colleagues of this different way of studying for an exam, because it's quite different with respect to what they were used to do in the past. And if you go to the next slide, we compared also the results of the CTF in the x-axis with the results of the written test. And as you can see, there are some situations in which there are students that were good in the written text, but did not perform as well in the CTF, and also on the other way around. So I do not have the mouse, but there are 3 students in the orange picture. They took 0 in the CTX, but they were quite they had an average marking in the written text. And on the other side, in the yellow, thank you, Gabriele, in the yellow slide, we have students, the two bottom dots in they got the maximum value for the CTF, but 0 and 1 for the written exam. I mean, so this allowed us to conclude, even though thank you, Gabriele, and you can go to the next slide. So the idea is that, well, we had a small sample size, but we think that also this question finds a positive answer because the CTF allowed us to consider some abilities that are somewhat difficult to validate with a traditional exam only. And if you go in the next slide, I have just a couple of points which are our lesson, the lesson we learned. First of all, it was very demanding for us, for the instruction to organize this training, because it requires the involvement of multiple people with different skills. Second, and very important, exam challenges and CTF challenges stimulate completely different players differently. CTF player, each time got to learn something new. So this is something we heard also yesterday during the Capture It workshop. So each CTF, even if you don't reach a top position in the ranking, are useful because you learn something new. Students sitting there for their exams, they want to show what they learned. They do not want to struggle on something new because it's a different situation. So they just simply want to show what they learned without struggling in looking in internet to find something new. So it's difficult for an instructor to find a good balance between these two types of exercise. And it's also very important, the evaluation is binary. Either you get the flag or you do not. If you do not get the flag, your exercise does not get any point. And this does not occur in your traditional exam, where you might want to mark also partial solution. So we need to find a way to be able to evaluate partial solution. And of course, we think that we cannot forget practical skills in cybersecurity. And then my last slide, sorry, I'm a little bit late, it's at the conclusion, and is that CTF competition, initially played by security enthusiasts, are now present in more formal education paths. Not only in Genova, they are also organized in other Italian universities and worldwide. So yesterday we heard about CTF organized at the Politecnico di Milano, Politecnico di Torino, University of Salento, but I'm sure there are many more. And this paired with another Italian program, which is the Cyber Challenge program, I think has helped us somehow to build a kind of ecosystem and a community where young talents which have a passion in cybersecurity are growing. And this is the positive message that I want to leave you with from my point of view as an educator in this field. And that concludes, because the next one is just a thanks slide. And if you have any question, I really apologize that I couldn't share the screen and I needed the help of Gabriele for this presentation.
Okay, thank you very much, Marina. My pleasure, actually, to help you in carrying out the presentation. So let me stop sharing because I need to check whether there are any questions from the audience. Okay, no questions. So actually, we are only slightly behind the schedule, but I really want to ask you one question. If you say that, let's say, your numbers confirm that people have learned while doing this kind of practical activities, apart for programming. But actually numbers are generated by self-evaluation. So people are giving themselves a score before the training part and after. Didn't you consider that perhaps the reason why they do not themselves as having passed through an improvement of their programming skills is because they had a wrong understanding of their skills in the first place. The reason why I'm thinking this is that sometimes when you learn security stuff, you also learn how to do security programming. So before doing this, you believe you know how to program things, and then after that, you understand that you were doing things in the wrong way. So perhaps did you consider asking these people whether they want to change their previous answer?
So I did not. I think you should move back. I think that after this training, students realize, those that were thinking of being good programmers, they realized that their skills were not enough. I mean, I don't know how to say in English, but the more you know what you don't know, because they see a broader, much more things. So I think that it's different types of programming. We needed to teach them Python and Python scripted, because you need to program fast, be fast, and know a lot of tools. And while in usual, at least in my department, in traditional programming courses, you use a single language and you do very basic exercise and you build on that exercise, and it's a kind of a repetition of the skill. And so it's a completely different way of approaching programming. This is my understanding. So maybe they improved, but they also realized that there is much more to learn. And so they were not so much self-confident in the end.
Yeah, I totally agree with you. I think the correct term is course of knowledge. So the more you know and the less confident you are about your skills and your capabilities. Okay, thank you very much, Marina. So this was our last presentation. I would like to thank again all the speakers and all the people attending this session. We are almost to schedule, just 10 minutes behind schedule. So I would like to wrap up with a very quick thought of mine. I think that we have seen many different presentations about very different topics that seem a bit far one from another. We have seen very complex environments such as cyber ranges, and we have seen educational paths as the one proposed by Marina, and we have seen hardware environment for hardware-based challenges. So I think this is a very good perspective, in the sense there's a lot of work that needs to be done for putting together all of these expertise, and I think this session, this track was very successful in putting together all of these different perspectives. So thank you very much again for your fantastic presentation, and well, let's stay with us also tomorrow for the last day of ITASEC. Thank you. Goodbye.
Thank you. Goodbye.